This lesson is on atomic structure, and the first thing that we need to do is identify the different parts of an atom, and so I drew this chart here. So subatomic particles, those are the different parts that make up an atom. So the first one is proton. The symbol for a proton is a P with a little plus sign, and that plus sign symbolizes its charge, which is positive. The location, the proton is located in the nucleus. And the mass of a proton is approximately 1 AMU. And AMU stands for atomic mass unit, which is kind of like saying we're measuring in grams. But since these are so tiny, we couldn't use grams, so it's measured in atomic mass units. The next subatomic particle is the neutron. The symbol for a neutron is an N with a little 0, and that 0 symbolizes its charge, which is none, no charge, or neutral. The neutron is located in the nucleus, and its mass is also approximately 1 AMU. And then the last subatomic particle is the electron. The symbol for an electron is an E with a minus. The minus symbolizes its negative charge. And the electron is located outside the nucleus. In its orbitals or in the electron cloud. And its mass is so tiny that compared to the proton and neutron, it is practically 0. So when we are looking at the mass of atoms, the mass only is coming from the protons and neutrons. It's not coming from the electrons at all. There's two numbers on the periodic table that you need to know what they are. That is the atomic number and the mass number. The atomic number equals the number of protons in the nucleus. It also equals the number of electrons in a neutral atom. So if you have a neutral atom, the atomic number equals the number of protons, and the atomic number equals the number of electrons. The mass number, which is also called atomic mass, is the total number of protons and neutrons in the nucleus. So it is your protons plus your neutrons. That's the only thing that make up your mass. So please remember this little equation to figure out your mass number. I drew a diagram here for those of you that want to see where those subatomic particles are located. So the middle section is the dense core. That whole thing is the nucleus. And that nucleus, we said, is made up of protons and neutrons. The protons are the ones that have the positive charge. And so those are the ones that I drew in yellow. The neutrons have no charge, so there's no charge drawn in there. These are the neutrons. So protons and neutrons make up the nucleus. The electrons, which I drew in purple, are outside the nucleus. And those have a negative charge. So on your periodic table you have a lot of symbols and a lot of numbers, and so I zoomed in on sodium so that we can label what all of those numbers mean. The top number, this 11, that is your atomic number. In other words, that is your number of protons. That is also your number of electrons if it is a neutral atom. The Na, that is your symbol. Below that will be the full name of the element. And the number on the bottom is going to be your atomic mass. Or we also said that could be called mass number. So the number on the top is the atomic number, the number on the bottom is the mass number. Now I wanted to look at just a few examples of looking at the periodic table elements and determining number of protons, neutrons, and electrons. So let's start with Be. Okay, this number on top, that 4, that is your atomic number, which means that is the number of protons. It is also the number of electrons. And then the number on the bottom, 9, this is your mass, which equals protons plus neutrons. Okay, so I know my protons are 4. I don't know my neutrons, but I know it equals 9. Okay, so my number of neutrons has to be 5. Let's look at calcium. Same thing, so the number on top, that 20 is my atomic number, which is my number of protons. It is also my number of electrons. My mass is 40. I know that protons plus neutrons equal my mass. Since I have 20 protons, I must have 20 neutrons, because 20 plus 20 equals 40. One more example, I'll do magnesium. Magnesium, the atomic number on top is 12, so that means I have 12 protons. That number also stands for the number of electrons, so I have 12 electrons. The mass of magnesium is, I'll have to go back to look, 24. Mass of magnesium is 24. Alright, so my protons plus neutrons equal 24. I have 12 protons, I must have 12 neutrons. So that is how you determine protons, neutrons, and electrons, by just looking at the periodic table. Now the last thing we need to talk about are isotopes. And isotopes are atoms of the same element that contain different numbers of neutrons, and so therefore have different atomic masses than what is listed on the periodic table. Now there are two ways to write isotopes. One way is that you will see is the name of the element. So for example, carbon -13. So what this is it's carbon and its mass is 13, or its mass number. The other way that you can see it written is 13,6 carbon. So these are the two ways that you will see isotopes written. I'm going to label what those numbers stand for. So this 13 is the same as this 13, and that is your mass number. The 6 on the bottom there, that stands for your atomic number. And so if you look at carbon on the periodic table up here, you can see that its atomic number is 6. And so that's where that 6 came from. So these are the two ways that you will see isotopes written. And so when we're labeling protons, neutrons, and electrons from this information, you know that the atomic number that 6 is your number of protons. It is also your number of electrons. However, your neutrons, you need to use this mass number that is given. And so mass number, your 13 equals your protons plus your neutrons. In this case, our mass number 13 equals 6, that's our number of protons, plus our neutrons. Alright, so you do subtraction to figure out your number of neutrons, which is 7. Okay, so the mass number is going to be different than what you see on the periodic table. Again, if we look at carbon, if you can see there, it says that carbon, the mass is 12. And so the isotope of carbon, the mass is 13. So it has a different number of neutrons. The number of protons doesn't change, number of electrons doesn't change, just the number of neutrons. We'll do another example. If I had an isotope of oxygen, and let's say I didn't know the mass. But I know that oxygen, if we look on the periodic table, oxygen right here, oxygen has an atomic number of 8. So 8 is going to go on the bottom. And I don't know the mass yet, but I'm going to tell you that it has, we know, 8 protons, 8 electrons, and if I said that it had 10 neutrons, you could take that information and figure out the mass. Again, the mass is protons plus neutrons. So 8 plus 10 equals 18, and that is my mass number, which is going to go on top here, and it's also going to go in front of that oxygen dash. So this is an isotope of oxygen 18. So with isotopes, that was just one example to show you that if you are not given the mass, that you find it by adding protons and neutrons. So you add your protons and neutrons. Do not get the mass off of the periodic table when you're dealing with isotopes, because it is going to be incorrect. Okay, I've got just 2 more examples for you on isotopes. So if the only information I gave you was that the isotope was copper 66, you could fill out all of this information here. So copper 66, we know that the mass number is 66. We know that the element is copper, and so we could look on our periodic table and find copper, which is right here. Copper, that number on top, that atomic number is 29, and so our atomic number is 29. Our atomic number stands for our number of protons, so protons equal 29. Also stands for electrons, so electrons are 29. Now our neutrons we need to figure out. Our mass is 66, and our protons are 29, so 29 plus our neutrons equals 66. So you do that subtraction and find that your neutrons equal 37. In other words, these two added together equal your mass of 66. Another example, if all I gave you was that your neutron number was 37, and your electron number was 28, and I wanted you to give me all of the other information, you could take that and say that your electrons are 28, so your protons are 28. That is also your atomic number. Your mass number is your protons plus neutrons. So we've got 28 plus 37, that's going to be 65. And so our mass is 65. We've got 28 protons, so we need to find what element has 28 protons. It is nickel. So your element is nickel. And it has a mass of 65, so it's nickel-65. And that is all your information. Now just remember, another way to write these